Hi there, you're in the lab with your mate JJ. Today is Module Monday. It's Module Monday. My silly job title for today is Electricity Guardian. I'm the Electricity Guardian. And the module that we'll be looking at today is an accelerometer / gyroscope. What we'll be doing, I'll pop you over the bench and I'll show you the module. Then we'll jump over the computer and get some information about it. Then we'll pop back over the bench and we'll plug it into an Arduino and program it and get some readings out of it. And then we'll wrap up. So first things first, let's jump over to the bench and have a look at this thing. Here on the bench, and this is our drawer. You can see the label on the front here is Accelerometer / Gyroscope. Now I've got two drawers. The drawer in the back is the GY-521, and the one in front is simply labeled MPU-6050. Now it turns out that the gyroscope itself, the part, is the MPU-6050, and then the rest of it's just controlling circuitry. So the GY-521 is just a breakout board for the MPU-6050. So I would expect that each of these will behave the same. You can see I've got 3 of the ones in the back and 1 of the ones in the front. So I think what we'll do is we'll do one of the ones from the back here today, and we might have a look at this other one next week. It'll probably be the same, so but we can confirm and just see if there's any differences or anything of note. So let me show you under the microscope. Just one second. All right, so this is the device underneath the microscope there. It's got some sort of a microcontroller or something on the board, bunch of passives, and I believe that this big honking thing here, I think that's the MPU-6050. So it's got a little gyroscope in there, which is probably mechanical, like a little motor sort of thing. That's what I imagine that is. I don't know much about them. Maybe we'll find out some information about the MPU-6050 when we duck over the computer in a minute. And you can see the various signals. We've got VCC, which is voltage in. We've got the ground, which is negative power. SCL for the clock. Is it SDA? I'm not sure. XOA, XCL, ADO, and INT. So that's 1, 2, 3, 4, 5, 6, 7, 8 pins for interfacing with the Arduino. So let's jump over to the computer together and see what we can find out about this thing. You're on the computer, and this is the RTL wiki, which is the wiki for the show. It's at inthelabwithjj.com/wiki. We're working through our Monday Module Monday series. On Monday, we take a look at a microcontroller module. So today we'll be looking at the GY-521. These are the ones that we've looked at previously. I've made some notes on the next page. Open that up there. So this page is subscriber-only material. It's available to people who support me on Patreon. So I'd love for you to join the ranks of my supporters, so feel free to do that. As it says here, this module is covered on Module Monday. I found a cheat sheet, a data sheet. So we'll pop that in the new tab. And then there's a tutorial on how to use the module that I found here as well. Actually, there's all sorts of material. If you search for GY-521, there's heaps of stuff out there to be found. I just picked these because they were close to the top of the results that I got. And someone's made a Arduino library for the module MPU-6050. Just to be clear, this is the actual sensor, is the MPU-6050, and this GY-521 is just a breakout board with one of these attached to it. And there's some links down here that you can follow if you want to buy them. The first one's at AliExpress.
There's all different ones at AliExpress, so feel free to shop around and get a good price. And this one was actually to an Australian electronics store that I stumbled upon, which is where actually I found the cheat sheet here. Sorry, I keep saying cheat sheet. The data sheet. So the data sheet's got 52 pages in it, which is a bit long for our purposes here today. So we won't be looking at it in depth. But if you're interested in this MPU-6050 module, then you'll be able to find heaps of information about it. I'll go through the table of contents with you now, and then we'll go over to the tutorial and work through that. So this starts with the revision history, then purpose and scope, product overview, MPU-60X0 overview, applications, features, gyroscope features, accelerometer features, additional features, motion processing, clocking, electrical characteristics, gyroscope specifications, accelerometer specifications, electrical and other common specifications, electrical specifications, continued, I2C timing characterization, SPI timing characterization, MPU 6000 only. Okay, so that SPI looks like it's available on this particular one and not on the 6050. Absolute maximum ratings, applications, information, pinout and signal description, typical operating circuit, bill of materials for external components, a recommended power on procedure, block diagram, overview, 3-axis MEMS gyroscope with 16-bit ADC and signal conditioning, 3-axis MEMS accelerometer with 16-bit ADCs and signal conditioning, digital motion processor, primary I2C and SPI serial communications interfaces, auxiliary I2C serial interface, self-test, MPU-60X0 solution for 9-axis sensor function using I2C interface, MPU-6000 using SPI interface, internal clock generation, sensor data registers, FIFO, that's first in, first out, interrupts, digital output temperature sensor, bias and LDO, charge pump, programmable interrupts, digital interface, I2C and SPI MPU 6000 only, serial interfaces, I2C interface, I2C communications protocol, I2C terms, SPI interface, MPU 6000 only. Serial interface considerations for the MPU 6050, MPU 6050 supported interfaces, logic levels diagrams for AUX VDDIO equals 0, assembly, orientation of axes, package dimensions, PCB design guidelines, assembly precautions, storage specifications, package marking specification, tape and reel specification, labeling, packaging, representative shipping carton label, qualification test policy, qualification test plan, environmental compliance. Purpose and scope. This product specification provides advanced information regarding the electrical specification and design related information for the MPU 6000, MPU 6050 motion tracking devices, collectively called the MPU 60X0 or MPU. Electrical characteristics are based upon design analysis and simulation results only. Specifications are subject to change without notice. Final specifications will be updated based on characterization of production silicon. For references to register map and descriptions of individual registers, please refer to the MPU 6000 or MPU 6050 register map and register descriptions document. The self-test response specifications provided in this document pertain to revision D parts with date codes of 1147 or later. Please see section 11.6 for package marking description details. Product overview. Might as well go through some of this high-level stuff with you. 3.1 MPU-60X0 overview. Motion interface is becoming a must-have function being adopted by smartphone and tablet manufacturers due to the enormous value it adds to the end user experience. In smartphones, it finds use in applications such as gesture commands or applications and phone control, in enhanced gaming, augmented reality, panoramic photo capture and viewing, and pedestrian and vehicle navigation. With its ability to precisely and accurately track user motions, motion tracking technology can convert handsets and tablets into powerful 3D intelligent devices that can be used in applications ranging from health and fitness monitoring to location-based services. Key requirements for motion interface-enabled devices are small package size, low power consumption, high accuracy and repeatability, high shock tolerance, and application-specific performance programmability, all at a low consumer price point. The MPU-60X0 is the world's first integrated 6-axis motion tracking device that combines a 3-axis gyroscope, 3-axis accelerometer, and a digital motion processor, DMP, all in a small 4x4 by 0.9 millimeter package. With its dedicated I2C sensor bus, it directly accepts inputs from an external 3-axis compass to provide a complete 9-axis motion fusion output. The MPU-60X0 motion tracking device with 6-axis integration, onboard motion fusion, and runtime calibration firmware enables manufacturers to eliminate the costly and complex selection, qualification, and system-level integration of discrete devices, guaranteeing optimal motion performance for consumers. The MPU-60X0 is also designed to interface with multiple non-inertial digital sensors, such as pressure sensors, on its auxiliary I2C port. The MPU-60X0 is footprint compatible with the MPU-30X0 family. The MPU-60X0 features 3 16-bit analog to digital converters, ADCs, for digitizing the gyroscope outputs, and 3 16-bit ADCs for digitizing the accelerometer outputs. For precision tracking both fast and slow motions, the parts feature a user programmable gyroscope, full scale range of plus or minus 250, plus or minus 500, plus or minus 1000, and plus or minus 2000 degrees per second, DPS, and a user programmable accelerometer, full scale range of plus or minus 2G, plus or minus 4G, plus or minus 8G, and plus or minus 16G. On an on-chip 1024 byte FIFO buffer, an on-chip 1024 byte first in first out buffer helps lower system power consumption by allowing the system processor to read the sensor data in bursts and then enter a low power mode as the MPU collects more data, with all the necessary on-chip processing and sensor components required to support many motion-based use cases. The MPU-60X0 uniquely enables low-power motion interface applications in portable applications with reduced processing requirements for the system processor. By providing an integrated motion fusion output, the DMP in the MPU-60X0 offloads the intensive motion processing computation requirements from the system processor, minimizing the need for frequent polling of the motion sensor output. Communication with all registers of the device is performed using either I2C at 400 kHz or SPI at 1 MHz for the MPU-6000 only. For specifications requiring faster communications, the sensor and interrupt registers may be read using SPI at 20 MHz for MPU-6000 only. Additional features include an embedded temperature sensor and an on-chip oscillator with plus or minus 1% variation over the operating temperature range by leveraging its patented and volume-proven Nasiri fabrication platform, which integrates MEMS wafers with companion CMOS electronics through wafer-level bonding. InvenSense has driven the MPU-60X0 package size down to a revolutionary footprint of 4x4 by 0.9 millimeters QFN, while providing the highest performance, lowest noise, and lowest cost semiconductor packaging required for handheld consumer electronic devices. The part features a robust 10,000 G shock tolerance and has programmable low-pass filters for the gyroscopes, accelerometers, and the on-chip temperature sensor. For power supply flexibility, the MPU-60X0 operates from VDD power supply voltage range of 2.375 volts to 3.46 volts. Additionally, the MPU-6050 provides a V-logic reference pin in addition to its analog supply pin VDD, which sets the logic levels of its I2C interface. The V-logic voltage may be 1.5 volts plus or minus 5% or VDD. The MPU-6000 and MPU-6050 are identical, except that the MPU-6050 supports the I2C serial interface only and has a separate V-logic reference pin. The MPU-6000 supports both I2C and SPI interfaces and has a single supply pin, VDD, which is both the device's logic reference supply and the analog supply for the part. The table below outlines these differences. There we go. So we won't read the rest of the data sheet, but it's there if you'd like to have a look at it. What we're going to do now is just have a quick look at this tutorial, and then we'll take it over to the bench, and we'll create the Arduino project. So the bits that we need are an Uno, some wires, a breadboard, and our module. So that's going to be pretty easy. It gives us the layout here, so that will be pretty straightforward. And then there's source code for the example. So we need the wire.h library, and that seems to be it. So oh look, there's a video tutorial as well. Anyway, there'll be a link to this tutorial in the show notes. So what I'm going to do now is take this over to the Arduino and get it working, and then when it is, I'll run you through it and see where we landed. All right, so here we are on the bench, and this is the Arduino Uno, and we've wired in our gyroscope / accelerometer. We only need to use 4 pins for this demo. VCC, positive 5 volts, ground, SCL for the clock, and SDA for, I guess, the data serial line. That's the I2C interface. It's wired through to the SCL and SDA lines on the Arduino. So that's everything there is to show you about the wiring for the project. What we'll do now is just pop over to the IDE and have a look at the code. And see our readings, pick up our readings. So I'll be back in a sec. So this code is from Michael Schoeffler. I don't know how to pronounce that name, I'm sorry. Written back in 2017, and it was taken from his website here. Actually, I might be able to link to the actual article. Yeah. So I'll just take that and stick it in here. Very good. Now we're going to save this, and we're going to save it as GY-521. Is that right? GY-521. Yeah, that's right. I'll just put gyro accel That'll do. All right. So, the first thing we do is include the Y.H header, which is it's part of the Arduino software, and it allows for talking to I2C device. So the address that we're going to be using is 68. There is another address, but we're not using it. There we go, it's 69. If you tie the 80 pin high, you can use the other address, which is 69 rather than 68, but 68 will work for us. Now, we've got these 16-bit integers. Actually, I'm just going to take a quick break. I'll be right back. All right, so I got myself a fresh coffee, and I'm ready to go through the software with you. So, as I said, I got this particular code from Michael Schaeffler, and I put the link to the article up here as well. All right. So did we discuss this already? Yeah. 068 is the I2C address, and then there's 1, 2, 3, 4, 5, 6, 7 16-bit values. And there's a temporary string here, which is used to format the 16-bit integer using sprintf. Very good. So it just formats into the same string every time. So the setup, we just set up the serial port at 9600 baud, and then we write 0 into this register to wake up the MPU-6050. So this basically just turns everything on, which is good, and then we loop. And in the loop, we begin an I2C transmission. We write 3B. So that's the first X. It's the accelerometer X reading, the high bit. And it says that that he got this value from the data sheet on page 40, and then he uses end transmission, which indicates that the Arduino will send a restart. As a result, the connection is kept active. So okay, and then then we request from the MPU address 7 times 2 bytes, or or registers. Yeah, okay. So that 7, it's 1, 2, 3, 4, 5, 6, 7. So 3 accelerometer, 3 gyro, and 1 temperature, and it's multiplied by 2 because each register has a high byte and a low byte. So once that's requested, we just read the data back off the wire. So we read the high byte, and then we shift it left 8 bits, and then we read the bottom byte. That's for the X, Y, and Z for the accelerometer. Looks like the temperature is in the middle there. That's only a single 16-bit integer, and then the gyroscope has X, Y, and Z components as well. So by the time we've done that, that's our 7x2 data, and then we just print it all out, and we use the convert function, which we saw earlier. That will make it suitable for display. So what we're going to do here now, you will see I've got this Arduino Uno set up on COM6. So I'm just going to upload the sketch, and that's going, and let's open the serial monitor, and let's see what we see. There it is. So that's our the first 3 values there are the X, Y, and Z coordinates for the accelerometer. Then the temperature is there at about 28 degrees. That might be about right. It's not quite that It's not that hot in here. My temperature says 25 degrees in here, so I think that temperature needs a bit of calibration there, or maybe it's just hot on the board. I don't know, but that's quite hot. And then the gyroscope has a bunch of numbers as well. So what we'll do, I'll just pop over to the board and let's shake it around a bit. And you see those numbers all started to change a bit there. Just I wiggle the accelerometer around and the values change. The temperature doesn't change though, which is what we'd expect. So yes, there's our accelerometer and gyroscope and temperature sensor all successfully wired in, talking over the I2C bus. And yeah, I think that concludes the demonstration. So I'll throw over the farewell cam and we'll wrap up.
That's a wrap. So that was pretty easy, wasn't it? We plugged in our GY-521 accelerometer and gyroscope, and we only needed to use 4 out of the 8 pins that are available on the breakout board. We integrated some demo code found in a tutorial on the internet, and everything worked beautifully, didn't it? I suppose it'd be cool to actually have some sort of like 3D model that was would turn around and show you what it was doing, but that might be an exercise for another day. The goal today was just to integrate the module with the code, and we certainly did that. So yeah, it's the end of the video. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.